So this is the next series. We are doing another question paper for chapter-wise question paper for paper 2 specifically. All the questions here are basically taken from paper 2 for starting from Jan 15 to Jan 19. So this is for unit 1 specifically. So we will be doing papers. So the first question that we have is from Jan 2015. Paper 2, of course, all the papers are from paper 2. All the questions are from paper 2. So let's solve the first one. So the first one that we have is number 4. Here they're just saying that you are investigating the stretch of rubber bands with different number of bands. So read the whole question at your own time, and I can just quickly skim through that. What is happening here is they're doing an experiment with different number of bands, and they're checking, okay, how much is the stretch for a different number of bands. So if you read here, number of rubber bands, if you use 1, the stretch is 43. If you use 2, the stretch is 28. If you use 3, the stretch is 21. For 4, they haven't given you the answer, but they have given you a picture here, and it says here that this picture basically represents the stretch for 4 bands. So we will get this one from this one here, this image. So if I try to zoom in carefully, I can see that, okay, we have a stretch here that looks like this. So we have, this is 19, we have here, and then we have, I know that each of this house is 0.1 meter, so this should be 18.8, this is 18.9, and the next one is 19. So if I move back here, I can write 18.8. It's already in centimeters, we don't need to care about it. The next question here, it says estimate the, this is done, we get 1 marks for this one. The next question says suggest 2 reasons why your estimate is not accurate. So if they want to know that why is it not accurate, then always refer to the experiment error that you have. In every experiment we will have some issues like parallax error. They have not mentioned about the parallax error. You can also write about zero error and any one of them, any one. And then for number second part, we will discuss that if you look here, this band is basically this a curve. So if you're putting a band here, if you're putting a band here, this basically varies your length. So it's not a very good experiment to do. Again, if you look here, you'll see that the bands are twisted. So you can either say that the bands are twisted. Don't just mention parallax error and zero error. It's not a good idea. So just talk something related to the experiment. Band is twisted, so you won't have exact readings. Or you can say that the hook is curved. Because the hook is curved, they will have different lengths at different places. So if I move to the next part, it says suggest how the student made this investigate a fair test. So they already say that this is a fair test. How is it done? If you lead, this is basically talking about the control variable. Control variable is something that you keep constant for the whole experiment. Here, if you see, it says that using a force of 5 Newton each time. That means every time you repeat the experiment, you have used a force which is equivalent to 5 Newton. So we can say it's only 1 marks, only one reason is good enough. We can say force is kept constant. Force is kept constant. Okay, the next part. Here it says the number of rubber band is a series of whole numbers. Name the type of variables. Here from this experiment we already know that the number of this is independent. The band number of bands is independent. But because it's talking about whole numbers, we'll say discrete variable. That means it can only exist in exact numbers, not this. Or you can also say independent variable. both of them will be correct, but just mention one of them in the exam. Don't mention both. So next question here. So it was asking you to draw a graph, display the graph. So I've taken all the results from this point and I have plotted a graph here. So the graph looks like this. And then in the last part, they ask you describe the relation between the number of bands and the stretch length. So if you can look carefully, what's happening here is you have for number one, it's more. For number two, it's decreasing, 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 and then it went constant, something like this. So for these ones, we can have an answer that this graph basically is an inverse graph. So you must know by now that this is basically that it's an inverse relation. So I can say that there is an inverse relation between number of bands and stretch length, S-T-R-E-T-C-H, D-C-H-E-D, stretched. Just gonna write it again. And then for the second marks, I'm just saying the graph is, even if it's inverse relation, it's not a non-linear graph. So I'm just gonna mention it's a non-linear graph. So this earns you 11 marks, which is good enough. We'll move to the next question now. Next question is from the year June 2015 for paper 2. So the first question we find is a question about momentum, where they're just asking you what is the formula of momentum. So this is very easy. This must be memorized. So momentum is equals to mass times velocity. So they just ask you the equation and you get 1 marks for it. The next question says what is the initial? So if we have a look at here, they have given you the velocity. So you need velocity to find the momentum and you need the mass. Mass is here. Again, it's important that you understand when we try to do the momentum, we use kg and meter per second. This is a unit as well. So because the mass is already in kg, we don't need to do anything. We'll just multiply and we'll say it's 13 meter per second. And then if we look at the result is straightforward. It's 3 kg meter per second. The next question here, it says here that when the skater throws a ball forward, okay, so this is an important concept. Before the person, let's say this is the person, and here is the ball. So as the person throws the ball here, she then moves backward as well. Of course, the amount that they move in opposite directions is different. So here they are asking, explain why she moves in this direction. So why the person throws the ball and the ball moves in this direction, but the person moves in this direction. So again, we know from the principle of momentum that momentum before and momentum after collision is same. So we'll use the same concept here. We'll say that because of conservation of momentum. So what conservation of momentum says is your before momentum and your after momentum should be same. So what's happening here, before momentum was 0. So when this ball moves in this direction, you have a positive momentum. And after momentum, after the collision, your momentum should be 0 as well. So you move on the other direction, and this is negative p, let's say. So your overall momentum after collision is still 0. So we can say momentum, total momentum, or sum of momentum is still zero again, because you have positive p on the right side, negative p on the left side, so that makes it zero. We are just going to explain the same thing here. So because of the conservation of momentum, so momentum of the ball and the person are equal and opposite. You could have used the Newton's third law as well here, because we know that Newton's third law is applicable here as well. You could have said that every action has its equal and opposite reaction. So if this is an action, you will have equal amount of reaction. So understand the ball will go further because the ball has less mass, but the person will go less, but eventually there will be a momentum. So we can say that momentum before collision is equal to momentum after collision, and they both are zero. This is a bit concept that you should have a look. This is explained more in the theories. So this will owe you 3 marks here, um, just because you're saying how this is working. The next question here is a very common question. They will ask you explain how the pad. So if you look at here, this person is wearing some pads here, right? The cushion pads. What this cushion pads basically do, or you must have seen batsmen wearing pads or keepers wearing gloves. All the reasons are same. So there's an idea that let's say a person is wearing a pad, right? In this example. So this pad has a cushion. So what it does is when something strikes it, it increases the impact time. So the impact time increases. So let's say you are hitting with a Newton of 10 Newton or 100 Newton per second. So what it does is it breaks down this energy. So now, because your time has increased from 1 second, your collision has increased to, let's say, 5 seconds. So your force is still same, but now you're having impacts of 20 newtons per second. So you eventually have 100 newton impact, but because your time has increased, so you are having less impact at a time. It's like 1 kilo ball fall down on your feet, and 100 gram of 10 balls falling after a time, not at one time. So the force will be less, your time has impact. And here is another important formula that you need to remember is force that we will use in explanation as well. Force is basically equal to change in momentum. So what this will do is change in momentum divided by the time. So you're just increasing this. If you increase this, eventually this will decrease. Let's explain this. We will explain that the time of collision or impact, in this case is impact, the time of impact will increase, and then we'll refer to this formula that because force is equal to change in momentum. This is also change in momentum by time. So the magnitude of force will decrease force will decrease, and that's how we save our bones from crushing down under. So this is something you can have other explanations as well, that you have reduced acceleration, or you could have explained this in terms of pressure as well, but we will look into that when we do those chapters. So it's so pads protects her knees. So this is the concept. Every time you see something soft, that is the concept, that what it does is instead of having the impact at one go, it basically breaks down the impacts. So instead of having a 100 Newton, it basically breaks down 20 Newton at 5 times. So you are more likely to survive this. This is it. We'll move to the next question. We're solving another question which is from June 2016, paper 2. So the first question asks you about the work done. Take your time and read the question. So it's asked you to write the relation. It's very easy. We know that work done is equals to force times distance. So work done is equal to force times distance moved. And because it's only 1 marks, this should be good enough. The next question asks you that calculate the work done. Here, it's important that you remember that this force must be in Newton and this distance must be in meters. Only then we can write in joules. So if we check here from the information, it's in meters and this is in Newton. So straightforward, we will just say, okay, work done is equal to 140 into 39, and this will give me a straight answer of 5510. Remember one thing, you might have different answers. Like if you do the calculation, you will have an exact answer of this, but we can just roughly write it down. It doesn't matter if you write this answer or this answer, anything approximate will be good enough as well. Now the next question here, it says state how much energy is transferred to the wheelbarrow. So here, how much energy is transferred? Definitely all the work done that you're doing is basically going to this energy here. That's what you're doing, because you're doing a work, and this work is this energy is basically being shifted to this wheelbarrow here. Another important information that might be helpful, that you know from the conservation, that energy can neither be destroyed nor be created. So of course all the energy in the real world that you want, that you have applied, will be going somewhere. So because it's also 1 mark, that means you don't need to do any calculation. You just need to understand the concept and write it down. And whatever you write here, remember to write the same answer here. Do not make a mistake of doing another answers, okay? This is the important question. So this is about now about moment. So here it says that, okay, now they have a pivot. We know that from the point of pivot, basically you get the rotation. And here they're asking you to indicate the center of gravity of this. Understand that center of gravity always works with the weight. So your weight here is 470. If you have an object, center of gravity is always at the center. That's why it's called center of gravity, right? The point from where the whole mass works. So definitely this is somewhere here, and you level it with an X. And sorry, because they're just saying to level it X, I won't use a dot. I will just straightforward say this is the X that is working here, straight on top of this line. This is important to understand. You cannot put somewhere else, because weight will act from this point. Weight will act from this point. If you're saying that weight is from here and your center of gravity is here, then it's a problem. You won't get this marks for that. Next question here, it says State the equation moment, force, and perpendicular distance. Remember, for moment, it's important that you say that moment is equals to force times perpendicular distance. Don't just write distance. Okay, perpendicular distance. So what does perpendicular distance mean? That if this is the distance, force must be at 90 degree with the distance, and this is the force. Okay, has to be with the 90 degree. Now calculate the force F. So here we can say that this is the pivot here, so I can say 0.6. Okay, first, because we are calculating the force here and you just need to use the moment, we will use some concept, and that's why they have given you 4 marks. So we will say that anti-clockwise moment is basically equal to clockwise moment. So here we just have 2 examples, so we don't need to very much look what is anti-clockwise, what is clockwise. I can just say that this moment, the turning effect that is being created by this is basically balanced by this force here. So I can say that, okay, I have a force in clockwise direction 470 times 0.6, because you're calculating this force and your distance will always start from the pivot. So we know that this is the distance. Now for anti-clockwise moment, like for this one here, you're moving on the opposite direction of the clock direction. So it's anti-clockwise. So this will be F times the distance. But the distance is this complete distance. Remember, this distance is from the pivot, okay? Perpendicular distance from the pivot. So if it's from the pivot, then you have to mention it's 0.6 plus this d is equals to 0.6 plus 0.8. So this is 1.4. So this will give me a rough answer of 200 Newton. Or if you get something else in decimals, that's fine as well. But this is good enough. Remember, you have 4 marks, so that means you need to do few steps. And yeah, this is it. If you understand it completely, it's good enough. You might want to show this distance calculation here as well. I just wanted to show you how it works. So I skipped it, but for you it might be helpful to show it here. And that's how you get 10 marks for moment and force. This is another question that we have from the same year, June 2016, and this question is about momentum. So they're again asking you momentum. Remember, the formula is momentum is equal to mass times velocity, and then it asks you to calculate the momentum. Again, the unit is there. Make sure you have the same unit. Just a shortcut. So when you look at 2 marks here, basically they offer you 2 marks just to do the calculations. So if you write the momentum mass 0.5 times 3.1, so your answer is 1.55. So just remember this thing. For 2 marks, you will always, this is equivalent to 2 marks, okay? So you get 1 marks for this step and you get 1 marks for this step. So if they ask you 3 marks or 4 marks, then that means there is something more that you need to do. Okay? We'll have a look in future as well with these sort of questions. Here it says the hammer stops quickly when it hits the nail. The momentum of this, okay. Again, here 2 marks. That means you need to just write a straightforward formula and you will get the answer from there. So we just discussed this in the previous question, that force is equals to change in moment divided by time. What is our change in moment? 1.55. and it reduces to what? It reduces to 0. So negative 0. Divided by what time? 0.07. So good enough. Again, we have the proper units. We will just say that, okay, it's 22 Newton. Okay, and then for part B, it's asking you, uh, as it enters the wood, the nail exerts a force on the wood. At the same time, the wood, okay, so now they're just saying the same thing. Remember, this is what we have learned from the Newton third law pair. So explain these two forces are related. How are they related? They are equal and they are opposite in direction. They are equal, they are opposite in direction. Next question is, both ends of the nail exerts a pressure when the nail goes into the wood. Explain why the nail exerts more pressure on the wood than it does on the hammer. So here this question is a bit different from momentum. We need to jump to pressure. Okay, so but this is worth doing it. It's not a very big deal. So if you look at this carefully here, for these things we have a very small area, right, compared to this area. So what it does is pressure is equals to force by area. So if your area is very small, this pressure becomes immensely high. That means if you divide it with something very small, a number very small, this variable will get very high. So we'll just say that, okay, forces, we'll just say the same thing here, that pressure is equal to force by area. I always suggest, okay, one more thing that I'll just discuss here. I'm just trying to explain the things so I don't write proper English, but when you're writing in the exam you should be having proper English. That's what the ask you in the front page as well. So always write proper answers. We are just discussing all the points, so I'm trying to skip the writing as much as I can and trying to explain it or put a focus on the explanation more. So here another 2 marks. So we will say that force on the wood and this are equal. Force on both wood and nail is equal, are equal. But because nail has smaller area, it exerts more pressure. But because nail has smaller surface area, it exerts more pressure. I'm pretty sure when you have read these chapters, you have gone through these examples, leg of an elephant or the heel of a woman. This is good enough. We get 9 marks, and the questions are pretty much repeated. So um, make sure you understand it, the first one very carefully. So for the next ones, it's just easy for you to follow up. The next question we are doing is from paper to PR, and it's from the year June 2016. If we scroll down, the first question here, without just looking, I can say that to state the relation between the mass velocity. So you can just write down the formula and you will get 1 marks for this. The next question here, it says that the mass of this, so here if you read the question initially, this boy has a mass of 43.2 kg and the skateboard here has a mass of 2.50. So what happens here, there's two different things. So this is the boy, let's assume. He has a mass of 43.2 and this is the mass, m equals to this. and we have a skateboard, but this skateboard is not moving before collision. This is before collision. And then after collision, that means after they collided, they joined together. So now the new mass of the boy and skateboard mass is 43.2 plus 2.5. Okay, so this is equals to 45.7. What we are actually finding is the mass of the total person. So if I look forward, what's happening? This is the boy, and if I draw here, this is the boy that has a mass of 43.2, and we have a skateboard, but this skateboard has a velocity of 0. So this is the mass of the boy. Velocity is 4.10. We get this information from here. Okay, and the skateboard here has a mass of this, though it has a mass of 2.50 because its velocity is 0, so its momentum is 0 as well. After collision, what happens? They join together and they move. So we already know that the new mass, I can say mass new is equals to 45.7, which is the combined mass of this and this in kilograms, both of them, and this is in meter per seconds. And we are trying to find the new VF, which is unknown. Now, if you go with the um, conservation of momentum, I know that this momentum plus this momentum is equal to this whole momentum. So I'll write the same equation, but because it's 4 marks, I'll just quickly do the calculation. 4.10 times 43.2 is equals to 45, or I can just break it down for you. 2.50 plus 43.2 times VF. If I make VF subject, then you can just say that, okay, then VF by calculation 4.10 times 43.2 divided by 45.7 is equal to 3.88 meter per second. So 3.88 meter per second. The next question here it says the boy holds a heavy ball as he stands on a stationary skateboard. The boy throws the ball while he is standing on the skateboard. Explain what happens to the boy and the skateboard. So we have done this question before as well. So here a momentum conservation of momentum is applied. So what will happen is the ball will, if the ball starts to move here, the person will start to move backward. And this is because of the third law as well, so you can explain in any ways. I'll go with the Newton third law explanation, or you can just say the boy, because it's asking you what happens, so you need to explain what happens to the boy. So I'll say the boy and the skateboard moves backward. Moves backward, or you can also say leftward because on the left side, because you can see that this ball is already moving on the right, so the person must be moving on the right. And or you can say in opposite direction of the ball, direction of the ball. This will bring you basically 1 marks. And now you need to say why is this happening, explain why is it happening. So you can say because of the conservation of momentum, or because of third law, because of, I'm just gonna write conservation of momentum, but it's also, you can also explain it using third law motion of Newton, conservation of momentum. But because this is a momentum calculation, or you have done the momentum calculation, it's better to stick with this. So you get 7 marks for this. Another question for the same year, June 2016, paper 2R. So this is the first question. You can see that there is a very complex. Go through the whole question. I have gone through. I'll skim through the answers. So the first question here is asking you describe how the lever arm is used to remove the bolt. So the bolt is here. So what you need to do if you want to move this bolt, you basically have to pull this on this side. There's no mean of pushing it this side because nothing will happen, right? So we will see, we'll just say that, okay, the bolt moves to the left. Or you can just say the lever arm or the bolt will move to the left. So lever arm moves to the left, to the left. So I will also add bolt because it's asking you the bolt. So why is the spring used? You have seen this in several places. So the spring basically what happens is when you pull it there, it will remain there, right? It will, let's say, remain it like this. So you don't want to leave it like this. So what we need to do is we attach a spring so that it comes back to its original position. So we will just, because it's just 1 marks, we'll just, we don't need to explain. We'll just explain that the to return the metal bar and the lever to the right. Okay. So what happened? You pulled it, this went like this, but you don't want this to be here because you want to pull it back again when you need it. So we put a spring. This spring basically brings it back here. You must have seen this in your doors and in a lot of places in your offices, those kind of places. Here it's a straightforward question, so it says the principle of moment. Without looking, you can just say anti-clockwise moment, anti-clockwise moment is equal to the clockwise moment at equilibrium. So what is the next question here? The force applied on B is 22. The distance from this is 3110 and 38 from A. So if we go here, this distance here from here to here is basically 110. That is the distance in centimeters. And this distance, basically this much, is 38 centimeter. And you need to, and there's also a force of 22 Newton here, if I'm not wrong. So here they're asking you to do the calculation for A. Of course, here, this rotation, if we consider this as the pivot, this will be the anti-clockwise rotation, and this force that you have here, if I use a different color, so this force that you have in this position on this side is basically the force that we are trying to find. Okay, so this force is clockwise direction. So for this one, the distance is 38. This one here, 38 centimeter. And of course, the other one is that. So I'll say F times 38 centimeter. 38 centimeter is equals to 110 times 22 Newton. Remember, because it's both centimeter here, we don't need to convert it. But otherwise, if you need to find something else, you need to convert it to meters as well. So here we are not bothering because it's this one in centimeters. So that's fine. And the equivalent for this is 63.7 newtons. Remember, we have used a formula where we have said that this F1 and D1 is equals to F2 D2. This is basically the principle of moment. So I'm just gonna write here so you understand, but in your exam you don't have to write it. Principle of moment. That's what we meant. Anti-clockwise moment is equals to clockwise moment. I write the answer here as well, and we get 3 marks for this. So the next question here is asking you explain how the force applied at B would need to change if the distance from the pivot of A is increased. So what they're saying is if this distance increases, the red distance, let's say now it's not here, let's say now it's this way, this is here, that means the distance has increased. So let's just understand what has happened. This moment now, moment is equals to F times D. Because D has increased, that means this moment has increased as well. And what we are doing here with this moment here, which is anti-clockwise moment, or I can just say AC moment, anti-clockwise moment, we are trying to balance this moment, right? So because your distance hasn't increased, this distance is the same, 110 centimeter, you need to increase this force now because your this moment has increased. In other words, if I show you, let's say I'm writing this is clockwise, so FCDC, so FCDC, and here anti-clockwise moment FADA. So this one has increased. This one is same. So you have to increase this because this one is constant. This is constant. So you have to increase this to compensate this increase that you have made. So we will just write the same thing here. We'll just say that, okay, since the distance to A is increased, since the distance A has increased, so the moment in that direction is greater now. Okay, this is 1 marks, and then you will say hence we need to increase the force. Hence we need to increase the force because the distance B is constant. So this is good enough. This is a good example. Although just when you go through this image, you will see that this looks very complex, right? So when I started, I had to go through a lot of things. Okay, how is this working? But what I'll suggest you for this question specifically is do not just try to understand everything on first go. Read the question. If you don't understand any part of it, move to the next part. Like this one is straightforward, right? So this was straightforward as well. So even if, don't waste too much time just trying to understand. This was a bit tricky, just 1 marks. So if you don't understand it, just move to the next one, and then when you are comfortable, move back. So this is a bit tricky one, I'll say, but you can deal it if you read the question very carefully.